Hey guys, welcome back for some more A-level maths revision. We're going to move on here in this video and look at small angle approximations. So it's pretty much the very end of chapter 5 here, looking at radians and arcsets and all that nonsense basically. So just to finish off this chapter here, we take a look at the small angle approximation. So this is new for the new A-level maths spec. Quite a brief little topic. So only a few questions in this video here. So let's take a look at them. So the first three here is just kind of looking at how we use the approximations, and the last two are just standard exam questions. So when theta is small, let's see if we can find the approximate values of these three expressions. So question 1a, so it's sine 4 theta minus tan 2 theta divided by 3 theta. So remember, for sine theta, that's approximately theta. Same for tan theta. That will also give us theta. And then for cos theta, let's just write this down as well. So we've got cos theta. This is going to be approximately 1 minus theta squared over 2. Okay? So using these three approximations here, we just need to substitute where appropriate. So for example, sine 4 theta, well, if sine theta is approximately theta, that means sine 4 theta will be approximately 4 theta. Tan 2 theta, so if tan theta is approximately theta, then that's going to be minus 2 theta, and we're dividing this by 3 theta here. So 4 theta minus 2 theta is 2 theta divided by 3 theta here. So the thetas will just cancel to give us 2 over 3. Okay, so a nice easy one there to get us started. Part B then, so this one's a little bit more complicated. We've got 1 minus cos 2 theta. So if we do the numerator first, so this is going to be 1 minus cos theta, so that's 1 minus, so it's going to be 1 minus. Where there's a theta here, so if this is 2 theta, this will be 2 theta squared. Like so. We divide it by 2. And then we're dividing the full expression by tan 2 theta times sine theta. So what's that going to be? Well, tan 2 theta, like we had here, that's just 2 theta. And sine theta is just theta. Okay. So if we simplify this numerator, 1 minus the 1 here, so they'll just cancel. And then we get minus this expression. Okay. So essentially this is just going to be positive. So all I've got left with the numerator is 2 theta squared divided by 2. So that's going to be 4 theta squared over 2. So if I write it out in full actually, so that's 4 theta squared over 2, which would be 2 theta squared. So that's going to be 2 theta squared. And this is divided by 2 theta times theta, which is 2 theta squared. So if we divide 2 theta squared by 2 theta squared, we just get 1. Anything divided by itself again will just give us 1 there. Okay. And then finally for part C here, 3 tan theta minus theta divided by sine 2 theta. Well, 3 times tan theta, so if tan theta is approximately theta, this is 3 times theta. We minus theta here, just like we've given in the expression, and then we divide it by sine 2 theta, so that's going to be 2 theta. So 3 theta minus theta is 2 theta, and we divide it by 2 theta again. And again, just like we had here, just give us 1 there. Okay. So like you can see, these questions aren't tricky at all. It's basically just kind of substitution. Be careful with, as long as you get these, you're okay. These are in the formula book, so you don't even have to worry about memorizing them. So in the formula book. Okay. So it makes life nice and easy. So let's take a look at a standard exam question now, taken from the same exercise here, exercise 5F. So question 5 here. When theta is small, can we show that the equation 4 cos 3 theta minus 2 plus 5 sine theta divided by 1 minus sine 2 theta, show that can be written as 9 theta plus 2. So all we need to do is use our approximations again. So cos 3 theta, so it's 4 lots of 1 minus, so it's 3 theta, so it's 3 theta all squared, remember. We divide that by 2. So that's the first part dealt with. We've got a minus 2, so we can't do anything with that. We've got 5 times sine theta. So sine theta is approximately theta, so that's 5 theta. Okay. And then in the denominator, it's 1 minus sine 2 theta, so that's just going to be 1 minus 2 theta. Okay, so let's try and clean this numerator up, see what we end up with. So 4 times 1 would give us 4. We've got minus, so 3 theta squared, that'd be 9 theta squared over 2. And then if you were to times that by 4, that would give you minus 36 theta squared over 2. So that would just simplify down to minus 18 theta squared. Like so. Okay, so 4 minus 18 theta squared. And what else do we have here? We've got the minus 2. And we've got the plus 5 theta. So I'm dragging it out in terms of steps here, but just so it's absolutely clear. So simplifying the numerator again, 4 minus the 2, so that's going to give me 2 plus 5 theta minus 18 theta squared. This is all over 1 minus 2 theta. Now at this stage here, I need to end up with 9 theta plus 2. Now it might not be immediately clear, but the issue here is I've got this quadratic in the numerator, and I've just got this 1 minus 2 theta in the denominator. So what I'm going to probably have to do here, to end up with just 9 theta plus 2, is to factorise the numerator, and then what we would hope for is that one of the factors is 1 minus 2 theta, so we'd cancel one of the terms in the numerator with the denominator, and hopefully the other factor would be 9 theta plus 2. So if we're factorising this, what we should expect is that one of the terms is 1 minus 2 theta, and really, the other one should be 9 theta plus 2. Okay? So if we double check whether this actually expands to give this, so for example, 1 times 9 theta would be 9 theta, 1 times 2 would give us 2, so that's good. Minus 2 theta times 9 theta, that gives us minus 18 theta squared. And then finally, minus 2 theta times 2, that would give us minus 4 theta, which gives you 9 theta minus 4 theta to give 5 theta. Okay, so that expands perfectly. So far, thumbs up, this is working. The denominator is 1 minus 2 theta, and that works perfectly. Like you can see here, that's going to cancel with that, and we just get left with 9 theta plus 2, as required. Okay, as we're asked to in part A. As required there. Okay. So just a standard example there. You know, we might see another example just like that in a moment. So that was part A. So if I just do part B over here, it's just dead brief. So we want to now hence write down the value of this full expression when theta is small. Now you can actually do part B even without part A, as long as they give you what it should be equal to, or what you can write it as. So because we're told it can be written as 9 theta plus 2, okay, what we're considering here is when theta is small, so when theta is small, so when theta is small, 9 theta will also be small, okay, so 9 theta will also be small. So what we do is we just disregard it, because it's essentially just, it doesn't really have an impact if it's that small, okay. So the idea with it being small is that we're just essentially kind of considering it to be very, very close to 0, okay. So when theta is small, 9 theta will also be small. So therefore, the value is just, that's 0 essentially. Well, we're just going to consider it as 0 just for the sake of making life easier. I'll just get left with plus 2 or just 2. Like so, okay. And there you have it. So there's one mark for, like I said, you can do that even without part A, as long as they tell you what it should be, or what it can be written as, for example. Okay? But they will often give you just what it should be written as. And then for this final question here, another pretty typical question, and you'll see it works pretty much identical to the last question. So again, part A, we just want to show that the equation can be written in a certain way, and then part B, we want to just work out the value of it. So, question 16 here. Part A. So when theta is small, can we show that this equation here can be written as 3 minus 2 theta? Well, let's have a go at using the approximations. So 7 plus 2 cos 2 theta. So that's going to be 7 plus 2 lots of 1 minus, so it's going to be 2 theta all squared, divided by 2. And then we divide this full expression here by tan 2 theta, so that'll just be 2 theta plus 3. Okay, so let's clean this numerator up. 7 plus 2, so that would be 9. Okay, so I've just expanded 2 times 1 and added it to 7. Now we've also got 2 times this expression here. So this will be 2 theta squared, so that's 4 theta squared over 2, so that's 2 theta squared. We've got the minus of that, and we times it by 2, so this is minus 4 theta squared. Okay. Don't think, yep, that's fine. No, minus 4 theta squared, good. And then denominator, just got 2 theta plus 3. Now, at this point here, again, I've got to just show that it can be written as 3 minus 2 theta. This isn't quite what we want at this point here, obviously. So again, we're going to want to factorise here. Okay, we want to get rid of this 2 theta plus 3 in the denominator, and just end up with a 3 minus 2 theta in the numerator. So for that, we're going to factorise this quadratic here. So if we do that, 2 theta plus 3, 3 minus 2 theta. Because like you can see, what we want to end up with is 3 minus 2 theta. We've got this 2 theta plus 3 in the denominator, so we've got to have both of these in the numerator. One to cancel, and one what we end up with. And then in the denominator, we've just got what we want to cancel. So 2 theta plus 3. That will cancel with that. So we just get 3 minus 2 theta as required. Okay, so pretty standard there. And part B here. So when theta is small, again, minus 2 theta will be also small. So okay, so minus 2 theta is also small. So the value will just simply be what we've got left here, which is the 3. Okay, so the value is equal to 3 there. Again, only 1 mark though, but like I said, you can do that even if you can't show that this expression is equivalent here like we've got in part A. But there we go. That brings us to the end of this video. Like I said, quite a small one. If there is anything that's unclear, please just let me know down below. But yeah, cheers.